Returning to this idea of self-play that you brought up a few minutes earlier, just to make sure that I understand how this might be a pathway forward to ChatGPT, for instance, being able to emulate a high-level philosopher, somebody who's competent in philosophy, is the idea that if you had two ChatGPT models just philosophizing back and forth, they would somehow be able to develop philosophical articles at the level of a philosopher?
This leads to another problem. The present systems are not set up for online learning. So the LLM is trained on static training data, and when the LLM has a working memory context, which is basically the prompt, it translates this prompt, which is written in a natural language, into hidden states of the model, and then projects it into a new prompt state. So there is something gets lost, of course, because you cannot translate every nuance into language and back. So maybe you should translate it into some kind of intermediate language. And then once it leaves the prompt context, it's lost. Mm-hmm. And you can, it behaves in some sense like a human being with anterograde amnesia, like in the movie Memento, where the main protagonist is unable to form new memories outside of the present working memory context. And you can deal with this to some degree by building mnemonics, by taking notes, and then building a protocol on how to access these notes, and by making the working memory context larger. You can also basically store the working memory context into a database, and once the database gets too large to access for you efficiently, you can retrain the database into the model. So basically you take it offline, it dreams at night, it sleeps, and then in the morning it wakes up having integrated this knowledge to some degree. And so in this way you can emulate human learning, but it's still not the same thing, because human learning is happening actively at this constructive frontier where you're building new ideas and then internalize them. And to do this, you probably need slightly different paradigms. It's something, for instance, that the startup that I'm currently working for, Liquid AI, is interested in doing and is working on, is to build systems, models that are fluid, that are constantly trainable, that you can, in principle, update in real time based on what's happening in real time. And if we could build systems that learn with the same efficiency as human beings, that they basically discover the relevance of the new generated stuff or the new inferences, and then is able to integrate them exactly in the right way and edit its own model on the fly in such a way that important information doesn't get lost, that you don't have catastrophic forgetting, and so on. That would enable things that are more human-like or even surpass humans, probably. But it might require extensions of how we currently train these models. And there is also this difficulty that we may not be motivated to put enough resources into looking for these extensions, because we can compensate just by training larger models and then fine-tuning them with the new results and so on. So there might be easier ways that don't force us to go back to the drawing board and go into this risky endeavor of trying completely new things that may not work. Mm-hmm. And may not result in something that works, just sticking with the stuff that already works and patching it and stacking on top of each other, even if it's more expensive and clunky and so on, to get to the same performance. And maybe this works too.
Is that what OpenAI is doing?
I think OpenAI is doing both. OpenAI is, on one hand, has teams that are scaling existing models up. Then they also, what they do is they work on explainability, which is something that everybody is doing, I think, at the moment who does serious AI research.
Explainability?
Yes, which means we are going into the models and we try to find out how does the model actually represent this. So when we have a model that has not learned this yet, and now it has learned it, what exactly is the thing that has changed in the model? And then we basically notice that there are rules that are implemented in the neural network in a particular way and in the particular modes of interaction with each other that produce that behavior. So the neural network, in some sense, is programming code. It's a program that is distributed and not human-made and extremely complex and fuzzy, and it's often also very redundant. And by trying to identify how it actually works, we learn about how knowledge is represented. And we can also learn how to constrain the model to produce exactly what we want and nothing else.
I think it's probably surprising to a lot of our listeners who aren't computer scientists that ChatGPT or these other LLMs are really black boxes, that we don't know what's going on inside of them?
I think it's more like that's the opposite. A lot of people think that neural networks are black boxes, but I don't think that's entirely true. So basically, there has been for a long time research on the mathematical principles of learning and how data are represented in models and under which conditions models learn and what it is that they're learning, what is the theory behind the models. And this is an extremely open and very active research field. But I wouldn't say that it's one where there are no more breakthroughs to expect it, because there are really lots of interesting open questions in this area, but it's also far from a black box. And of course, because the model is not made out of a rule base, but it's a neural network that in some sense is an unprincipled reasoner, where you don't know what every bit means. And often a bit doesn't mean something, but it's only many bits together in a given context are on average meaning what you want. Right? It's more brain-like in this way. It's often difficult to get to the explainability, and it might require enormous resources to filter out of the neural network why it actually works in this context and so on. And these are two things that I mentioned. So basically scaling up models, finding better training paradigms and so on, and working on explainability. But another thing is also trying completely new things. And there are, of course, all the large teams have people who try to do new things, which often means we try to combine ideas from other fields with this, from physics, from statistics, and from game theory, and from econometrics and so on, and they often lead to important insights in how to build a model, or how to make mathematical advances on building more efficient representations and so on. Or also a lot of practical engineering, where people have a bunch of ideas and say, I don't know if this is going to work in practice, and then surprisingly some things work that you didn't expect to work, and other things that you thought might work don't.